All right, deep dive time. Today, we're going to tackle something super important in software development, integration testing.
Okay.
You know, we got to make sure that all the pieces of code work together, not just, each little piece by itself.
Yeah. It's like making sure all the parts of a machine work together, right?
Exactly. So we don't end up with a Frankenstein's monster of an application,
Uh-huh.
right?
That's a good one. And our sources today, they really highlight that integration testing, it's all about catching those gotchas that pop up when things that work fine on their own, when those modules collide.
Oh, yeah, when they collide. So,
Okay.
I always like to dig into the why. Why do those modules sometimes act up?
Well, you got to think about it. Different developers, they might have different logic in their code. Or,
Sir?
sometimes those client requirements, they shift mid-project.
Oh, for sure.
And those database interfaces, those can be tricky. And even just how exceptions are handled
Yeah.
can cause total chaos during integration.
Oh, yeah, total chaos. That sounds familiar. So our sources, they actually give a really clear example. They talk about a login page, a mailbox module, and a module for deleting emails. And you can think about it, each of those, they work perfectly fine on their own.
Right.
But, imagine the login sends your credentials.
Right.
And that mailbox module is just sitting there like, what am I supposed to do with this?
Uh-huh.
Or the delete button, it works perfectly fine.
Right.
But that email just refuses to leave your inbox.
Yeah. It's super frustrating for users and a nightmare to debug.
I bet. So integration testing is making sure all these different parts, they're speaking the same language.
Exactly, working together harmoniously.
All right, so let's say we're convinced we got to do this integration testing, it's important, but how do we actually do it?
Okay.
Our sources, they outline a few different approaches.
Yeah.
And the first one they mention is the Big Bang approach.
Oh, yeah.
I'm already picturing like an explosion of code.
It can feel a little like that sometimes.
Ugh.
Basically, it's you integrate everything at once, and then you test that whole system as one giant unit.
Okay.
It can feel tempting. It's like, ripping off a Band-Aid.
Rip it off.
Blah.
But there's always a but.
Always. Our sources point out that if something goes wrong in that giant tangled web of modules,
Oh, yeah.
finding the cause can feel like, ooh, I don't know, searching for a needle in a haystack.
A big haystack.
Right. And then it's easy to miss testing some of those interfaces.
Right.
And we won't even get started on the pressure that puts on the testing team.
Oh, man, I bet.
They're scrambling. Very little time to really thoroughly test everything.
Yikes. So maybe the Big Bang is not the best approach for someone who gets stressed out easily.
Yeah, maybe not. So that's where this incremental testing comes in.
Incremental testing. Okay.
So instead of that massive all at once, we gradually integrate and test the modules in smaller groups, logical groups.
Okay, so it's a little more manageable.
A little less overwhelming, more focused testing.
Okay, I'm feeling calmer already. But hold on. How do we test these groups if some of the modules, they aren't even finished?
Yeah, good question. What do we do?
That is where we use stubs and drivers.
Stubs and drivers. Okay, those sound interesting.
These are tools that let us test even when parts of that system are still being built.
Okay, so what are they exactly? How do they work?
So think of a stub as a stand-in for a module that's missing.
Okay.
So let's say you're testing module A, right?
Yeah.
And it needs to interact with module B, but module B is not ready yet.
Right.
You can create a stub for module B, and it basically mimics the responses, just enough so that you can test those interactions.
So it's like a little placeholder that says, hey, I'm here. I'll respond in a certain way, but I'm not actually doing anything yet.
Yeah. And a driver that acts like a remote control for a module that's missing. It simulates those calls that a higher level module would make to a lower level one that's not ready yet.
Oh, so a stub is a placeholder that responds.
A driver is a placeholder that initiates.
You got it. And these are essential for the two main incremental approaches.
Okay.
Bottom-up and top-down testing.
All right, so let's unpack those. Bottom up, it sounds like we're starting with the foundation and building up.
Yeah, exactly. You're starting with the lowest level modules, the ones that don't depend on any others. You test those first, and then you gradually integrate and test higher level modules that depend on them.
So you're building a nice solid base before adding the next layer. What are the advantages of that?
One big plus is that it's easier to isolate faults.
Oh, okay.
Because you're testing in smaller units. So it's much simpler to pinpoint where an error is coming from. And you also don't have to wait for all the modules to be finished.
Right. Okay.
You can start as soon as those lower level modules are ready to go.
That makes sense. That's efficient, but there must be some drawbacks. There's always a trade-off.
Right. Nothing's perfect, right?
Right.
One potential downside of bottom-up is that those critical high-level modules, they're tested last.
Oh.
So any major design flaws in those modules might not be discovered until really late in the process.
So if there's a fundamental problem with, like, a key module design,
Yeah,
you might not find out until you've already built most of the system on top of it.
exactly.
Oof, that's a lot of rework.
Yeah, it could be. And another potential issue is that you can't create an early prototype of the system.
Oh, right.
You have to wait until most of those lower level modules are integrated and tested before you have something to show.
Okay, so bottom-up has its pros and cons. What about top-down integration testing? Is that just the opposite?
It is kind of
Okay.
top down. You start at the top of the system, those high level modules,
Yeah.
and you work your way down. And we use those stubs we were talking about to stand in for any of the lower level modules that aren't developed yet.
So you're essentially testing the control flow and the logic of the main parts of the system first, even if, like, all the details aren't there yet. This sounds like it could be really good for getting early feedback on the overall design.
You're right, and that's one of the big advantages of top-down testing. You can create that early prototype, even if it's not totally functional. And that can be really valuable for getting feedback from stakeholders, right?
So you're not just testing in a vacuum. You're involving those stakeholders early on.
Exactly. Plus, just like bottom-up testing, fault localization is generally easier
Right.
because you're dealing with those smaller, more isolated units at each stage.
Right.
And since you're testing those critical high-level modules first, you're catching those major design flaws early on.
Okay, so top-down sounds like it addresses some of the weaknesses of bottom-up. But I'm guessing there are some trade-offs here as well.
Oh, there always are. One potential downside is you often need to create a lot of stubs
Okay.
to simulate all those lower level modules,
Right.
and that can add some complexity.
More moving parts, more potential for things to go wrong.
Potentially, yeah.
Okay.
And the other issue is that those lower level modules, they might not be tested as thoroughly as they would be in a bottom-up approach because they're kind of treated like black boxes until later.
Okay, so each approach has its own, like, strengths and weaknesses.
Yeah.
It sounds like choosing the right approach really depends on the specific needs of the project, what you're
Right.
trying to do.
Exactly. That's why understanding these different approaches and like the nuances of each is so important, right?
Yeah.
So you can make informed decisions about how to best test your software.
So we've got bottom up, we've got top down.
Mm-hmm.
Our sources also mentioned something called sandwich testing.
Oh, yeah.
Is this some kind of delicious hybrid approach?
You could say that. It takes the best of both worlds. It combines top-down and bottom-up.
So are we testing top down and bottom up simultaneously? How did that even work?
Kind of. So with sandwich testing, you test those high-level modules
Yeah.
using stubs for the lower-level ones, just like top-down.
Okay.
But at the same time, you also integrate and test those lower-level modules using drivers,
Yeah.
just like in bottom-up.
Oh, okay. So you're doing both at the same time. I can see how this would provide, like, the most comprehensive coverage. You're not neglecting any part of the system,
Right.
but I gotta admit, it also sounds like it could get really, really complex.
It can, but it's a powerful technique for complex systems where you need that extra level of assurance.
Okay.
It does require a lot of careful planning and coordination to make sure everything is being tested thoroughly and efficiently.
So we've got a pretty good understanding of all the different approaches to integration testing.
Mm-hmm.
But is it really as simple as, like, picking an approach and just running some tests?
Not quite.
Right.
Our sources really emphasize that integration testing, it's more than just running tests.
Oh, right.
It starts with a good, solid plan.
Of course. Failing to plan is planning to fail.
Mm.
What makes for a good integration testing plan?
Well, the first step is choosing the right approach for your project, right?
Right.
We've already talked about the pros and cons of the different options, so you can make an informed decision based on your needs and the complexity of the system.
Right. No point in going for the big bang if it's just going to, create more chaos.
Exactly.
What else do we need to think about?
You need to define the scope of your testing very clearly.
Okay.
What modules are you going to include? What interfaces are you focusing on? What specific goals are you trying to achieve?
So it's like creating a roadmap for our testing journey.
Exactly. We got to know where we're going before we start driving, right?
Right, exactly. You need a destination.
What about roles and responsibilities?
Yeah, that's important.
Who does what in this adventure?
Right, who's in charge of what?
A good plan will clearly outline who's developing the test cases, who's executing them, who's tracking defects, who's responsible for reporting the results.
So no confusion.
No confusion.
Okay.
What about those technical aspects of the plan?
Okay, that's a good point. What are those?
You also need to establish the testing environment.
Okay.
What hardware and software will you be using? What data do you need?
Oh, right.
How are you going to simulate those external systems or dependencies?
So it's like you're setting the stage for testing to take place.
Exactly. But things don't always go to plan.
Oh, never.
Right, and software development
Yeah.
always twists and turns. So that's where risk mitigation plans come in.
Oh, okay.
A good plan will identify potential risks up front and then have strategies in place to address them.
So, for example, what if like a key module is not ready on time
Yeah,
or the testing environment is just not stable?
exactly. Those are really common problems. So having those backup plans is crucial to keeping things on track.
So a well-thought-out plan addresses all these things to make sure our integration testing is thorough, efficient, and ultimately successful.
You got it.
So we've got our plan in place, our roadmap is ready. What's the next step?
Now it's time to design those all-important test cases.
Ooh, okay. But before we get into all of that, we've covered a lot of ground already. We've explored why it's so crucial, delved into the different approaches. We've even started to map out our testing plan.
Yeah, it's been quite a journey already.
And we're just getting started. In part 2, we'll continue our exploration. We'll dig into the details of test case design and uncover some expert tips.
All right.
So stay tuned because this deep dive is far from over.
Absolutely. Welcome back to our deep dive into integration testing.
All right.
Last time, we kind of explored different approaches, best practices, how it all fits in the software development lifecycle. It's a critical process, making sure those different software modules, they work together.
Exactly. We talked about the importance of, having a good plan, designing those test cases,
Yeah.
establishing those clear entry and exit criteria. We even got some great expert tips, right?
Right.
But there's one more thing I think we need to unpack here.
Okay.
The types of integration testing.
Ah, yes. We did touch on some of the key approaches. The Big Bang, incremental testing, that intriguing sandwich method. But within those, there are like specific types that cater to different needs and system architectures.
Okay, let's break it down. What are those types? How are they different?
Well, one common type is system integration testing.
System integration testing, okay.
This focuses on verifying the interactions between different systems, not just, modules within one application.
So it's like taking it to that next level. We're not just looking at how different parts of our software are working together,
Right.
but also how our software integrates with, like, databases, external APIs,
Yeah.
other third-party applications.
Exactly. Think of it like your software, it might be perfectly integrated internally,
Right.
but if it can't talk to those other systems, you're still going to have problems.
Right. It's like having a car that can't connect to the GPS or play music.
Exactly. Frustrating. So system integration testing makes sure those external connections are working.
Okay, so we've got that. What other types are there?
We also have component integration testing. This focuses on the interactions between different components within a single system.
So if system integration testing is about those external connections,
Yeah.
component integration testing is more about like the internal harmony.
Exactly. Making sure all the different components within your system, like those modules, libraries, microservices, they're communicating, working together as they should.
This reminds me of this product I was working on. The front end and back end teams, they were like ships passing in the night.
Oh, yeah.
Their individual components worked fine, but when we tried to integrate them, disaster.
Yeah, component integration testing would help there. Catching those issues early is so crucial.
For sure.
And speaking of user experience,
Yes.
we also have user interface integration testing. This focuses specifically on how that user interface interacts with all the stuff happening behind the scenes.
Okay, so this is like making sure the buttons, the menus, the forms, all the things that the user interacts with, they're working correctly.
Right. They're triggering those right actions behind the scenes. You're verifying that that user interface is like seamlessly integrated with everything else.
Okay, got it. So we've got system integration testing for external, component integration testing for internal, UI integration testing for that smooth user experience. Anything else we should know about?
There are a few more specialized types, depending on the specific architecture technologies involved. We've got API integration testing.
Yeah.
That's focusing on the interactions between different APIs.
So in today's world, with all these interconnected applications, services, APIs are crucial. You got to make sure those APIs are talking to each other, exchanging data.
Absolutely. Then there's data integration testing. This makes sure that data is flowing correctly between all the different systems, components.
This sounds really important for Like systems that deal with large data sets, you know, analytics, reporting.
Exactly. Data integrity is key. And then finally, there's continuous integration testing. This is all about integrating and testing those code changes frequently, automatically.
So this is where CI/CD comes in.
Exactly.
We're not just testing at like specific points. It's happening continuously throughout the development.
Right. And this helps catch those issues super early on, reduce the risk of any major problems down the line.
So it's a whole spectrum of integration testing types,
Mhm.
each one tailored to address specific needs, system architectures. How do we know which one is right for our project?
Yeah, that's a great question. There are several factors, right? Complexity of your system, the technologies you're using, the level of risk, your development methodology.
Just not a one-size-fits-all situation.
Not at all. You
Yeah.
might even use a combination of different types.
Okay. When we started talking about integration testing, I was thinking about all the technical details, the
Yeah.
code, the tests, the tools, but you've really highlighted the importance of the human side of this process.
Oh, absolutely. It's not just about the technology. It's about communication,
Yeah.
collaboration, making sure everyone's on the same page.
Right, from the developers to testers, project managers, stakeholders, everybody needs to understand how important this is, right?
Yeah, it's a team effort. And
Yeah.
good communication, that's key.
Especially when we're dealing with distributed teams
Mhm.
or, those remote work
I
situations.
know for sure. When everyone's spread out,
Mhm.
it's essential to have those strong communication channels and processes in place. Make sure everybody's on the same page.
Right, those virtual water cooler conversations, those are even more important.
Yeah.
But let's get back to the technical stuff for a minute. What are some of the key tools, technologies?
Oh, there's a wide variety, from those open source frameworks to those commercial solutions.
Mhm.
Popular ones, you've got Unit for Java, Unit for .NET, PyTest for Python, Jasmine for JavaScript.
So choosing the right tools really depends on what you're using, right?
Exactly. And a lot of those tools, they offer features like, automated test execution, test reporting, integration with those CI/CD pipelines.
Right, okay, so the tools help with, like, the mechanics of the testing. But what about the actual process of designing the tests? Any specific techniques or methodologies?
There are several approaches to test design, each with their own, pluses and minuses. One that's really common is black box testing. You're designing tests based on the system's behavior without knowing how it's actually implemented.
So it's like treating the system as a mysterious black box. We give it some input,
Yeah.
we see what comes out,
Exactly.
we make sure it matches our expectations.
This is good for testing the overall functionality, making sure it meets those requirements.
Okay. What about the opposite? Like,
Yes.
is there white box testing?
There is. White box testing, or sometimes glass box testing, involves designing tests based on the actual structure and logic of the system.
Okay, so we're peeking inside, targeting like specific components, paths, conditions.
Exactly. Verifying the correctness of specific code segments, logic branches.
So black box for overall, white box for internal logic. Any other techniques?
We also have gray box testing,
Gray box.
which combines those elements of black box and white box.
Oh, a hybrid approach. We have some knowledge, but we're
Yeah.
still focusing on that external behavior.
Exactly. This is often a good middle ground. You target specific areas while still keeping that focus on the overall functionality.
Okay, so black box, white box, gray box. What about those test cases we mentioned? How do they fit into all of this?
Yeah. So test cases, these are specific scenarios that you design to test the system. Each one defines the inputs, the expected outputs, any conditions that need to be met.
So it's like a recipe for the test.
Yeah, a recipe. We have our ingredients, those are the inputs, and we expect a certain dish.
Okay,
That's our output. And just like a good recipe, a well-written test case, it's clear, concise, easy to follow.
right, no room for ambiguity.
Right. We need to make sure everyone involved understands what it's supposed to do, how to interpret the results.
Absolutely. As we're wrapping up this part of our deep dive,
Yeah.
there's this question I keep thinking about.
Okay.
We talked about the importance of integration testing, the approaches, the tools, the techniques.
Right.
But is there ever a point where it's too much?
Ah, that's a good one. And that sparks a lot of debate, for sure.
Mhm.
There's definitely that point of diminishing returns. You can spend so much time on testing, it actually slows everything down,
Okay.
delays the release.
Right, so it's about finding that sweet spot.
Exactly. We need thorough testing, but we don't want to get stuck in unnecessary or redundant tests.
Right, prioritize, make sure those high-risk areas are covered, but you don't have to go overboard on things that probably won't cause problems.
Exactly. And it's important to really understand your goals, the level of risk you're willing to accept.
This brings us to a really important point. How do we figure that out? How much is enough?
That's the million-dollar question. There's no single right answer that applies to everything. But there are some things to consider.
Okay, let's dive in. What are some of those things?
Complexity of the system. That's huge.
Hmm.
A more complex system, lots of interconnected parts, that's going to need more testing.
Right, more moving parts, more potential for something to go wrong. Makes sense. What else?
The technologies, they matter too. Some technologies are just more complex, more prone to problems. So if you're using something brand new or integrating with a system that's known to be a bit finicky,
Yeah.
you want to be extra careful.
Right, uncharted territory.
Exactly. Then you've got the level of risk.
Risk, right.
What happens if there's a failure? If a bug could have serious consequences?
Financial security, safety.
Exactly. You're going to need a lot more testing to minimize those risks.
Higher stakes, higher testing.
For sure. And finally, your development methodology.
Okay.
If you're using Agile,
Yeah.
you're probably doing a lot more frequent incremental testing.
Right, Agile is all about those short sprints and feedback.
Integration testing, it becomes an ongoing process, not a one-time thing.
Okay, so no magic formula.
Nope.
We need to think strategically, prioritize,
Yeah.
make informed decisions.
Exactly. And remember, it's better to err on the side of caution,
Mm-hmm.
do a little bit more testing than you think you need, catch those issues early.
Okay, this has been so insightful.
Yeah.
But before we jump to part 3,
Hmm.
I want to leave our listeners with something to think about.
Okay.
How can we use automation
Oh, yeah.
to make integration testing more efficient?
Good one.
What are some of the trends in automation that are changing software development?
That's a great question. Join us in part 3 as we explore those fascinating aspects.
Welcome back, deep divers. We're wrapping up our exploration of integration testing.
Yeah.
You know, the unsung hero of the software development world.
Mm-hmm.
So far, we've uncovered why it's so important. We've looked at different approaches,
Right.
even delved into the human side of testing.
We've covered a lot. From test case design to choosing the right type of testing.
And remember that cliffhanger we left you with last time? We were about to unravel the mysteries of automation.
Oh, yes. Automation. It's not just a buzzword.
Right.
It's a game changer. As software gets more and more complex,
Yeah.
we need testing that's faster, more reliable, and automation is the key.
All right, let's break it down. How can automation, supercharge our integration testing? I'm ready to be impressed.
Well, think about speed for a minute.
Okay.
Automated tests, they can run through hundreds, even thousands of test cases.
Wow.
Way faster than a human. One of our sources, Software Testing for Dummies, they put it pretty bluntly. Time is money, and manual testing is a time suck.
Oh, I've definitely been there.
Yeah.
But speed isn't everything, is it? What about accuracy? Consistency?
That's where automation really shines. They execute the exact same steps, same inputs,
Right.
every single time. No coffee breaks, no distractions, no, oops, I clicked the wrong button moments.
So we're getting rid of human error, those inconsistencies.
Yeah.
Okay, I see the appeal. What else does automation do for us?
Well, flexibility and frequency. You can schedule them to run overnight, on weekends, even trigger them automatically when new code's committed.
Oh.
It's like having a tireless testing robot.
This reminds me of this one project. We were really struggling to keep up with the testing. It was slowing everything down,
Oh, yeah?
manually running the same tests over and over.
Yeah.
If only we'd had automation back then.
I know, it's a common problem.
Right.
But automation, it fixes that. And it goes hand in hand with CI/CD pipelines.
Right.
Every single code change, it's tested automatically before it's deployed, catching those issues early.
Okay, so faster, more consistent, more frequent testing. This all sounds amazing. But is there a downside? Are we all going to be replaced by robots?
Haha, that's the question, isn't it? But the answer is a definite no.
Okay, good.
Automation, it's great for those repetitive tasks.
Right.
But it can't replace human ingenuity. Humans, they design those clever test cases. They interpret the results. They see those subtle things an automated test might miss.
So it's not humans versus robots.
Not at all. It's more like a team,
Okay.
a dynamic duo, each playing to their strengths.
I like that. So automation takes care of the boring stuff. Humans can focus on strategy and being creative.
Exactly, augmenting our abilities.
Okay. But there's another big thing out there. AI.
Yeah.
How is artificial intelligence changing integration testing?
Well, AI and machine learning, they're opening up some really cool possibilities.
Yeah.
Imagine being able to analyze tons of data,
Right.
find those patterns, even predict problems before they happen.
Wow, that's next level.
Yeah,
So it's not just automating the tests, it's making them smarter.
exactly. We're seeing AI-powered tools that help design better test cases, pinpoint the high-risk areas,
Right.
even suggest fixes. It's like having an AI guru on your team.
This sounds incredible. Is this really happening?
Yeah.
Or is this like future stuff?
It's still early days,
Okay.
but it's gaining momentum.
Yeah.
Companies are already using these AI tools, and we're going to see way more in the next few years. It's definitely something to watch.
All right, so automation is making things more efficient. AI is adding intelligence, prediction. What about the tools themselves? What's hot in the integration testing world these days?
Cloud-based testing platforms are big right now.
Okay.
They're scalable, flexible, and they're cost-effective, way more than traditional solutions.
So instead of investing in all that hardware, maintaining those environments,
Yeah.
you can just spin it up in the cloud, run your tests.
Exactly. And cloud platforms, they usually have access to way more tools and resources, so you can find what works best for your project.
Okay, cloud-based testing, that's on my radar now. What other trends are out there?
Well, you can't talk about software these days without mentioning containers and microservices, right?
Right.
They're changing how we build software, and they're impacting testing too.
Right. Microservices, it's all about breaking down those big applications into smaller services that can talk to each other.
Right.
So that definitely changes how we think about integration testing.
Instead of testing how giant modules fit together, we're now testing the interactions between these little services. It's a new challenge, but it opens up new opportunities too.
Right.
We can test each one in isolation and then really focus on how they integrate. There are even specific techniques like contract testing, service virtualization.
So we're not just trying to use the old methods in this new world, we're coming up with new solutions.
Exactly. It's a really exciting time to be in testing.
Yeah.
There's so much innovation happening, and the tools, the techniques, they're evolving all the time.
This deep dive has been amazing.
It has.
We've learned so much from the basics to what's coming next.
Yeah, it's been a great journey.
And as we wrap things up, I want to leave you with this. Integration testing, it's about more than just finding those bugs. It's about confidence, quality, making sure the software works.
Right.
Embrace it, stay curious, and keep pushing the boundaries.
Well said. Testing is a journey, not a destination.
Keep learning, keep experimenting, and keep building that amazing software. That's a wrap on our deep dive into integration testing.
Thanks for joining us.
But catch you next time for another exploration of all things tech.